Okay, here's some help on your homework. So we're solving these equations for answers on the particular interval and also for all solutions. So what we're going to do here is find the inverse sine of both sides. So theta is inverse sine of negative square root 2 over 2. And you can think of that as inverse sine of negative 1 over square root 2 if you want to unrationalize it, because that way it's easier to picture with your reference triangle. So think about where sine is negative. Sine is negative in quadrants 3 and 4. And sine is opposite over hypotenuse, so we would put the 1 or the negative 1 on the opposite and the square root 2 on the hypotenuse. And so we realize that we have a 45, 45, 90 triangle with a 45-degree reference angle. So our answers are, what would that be? 225 degrees and 315 degrees. But we're going to put these answers in radians. And so 225 degrees would be 5 pi over 4 radians, and 315 degrees would be 7 pi over 4 radians. So for part A of the problem, that would be our answer. These are the only two answers within the interval from 0 to 2 pi. And for part B of our problem, what we want to do is take each of those answers and add 2 pi n to represent all of the answers that are coterminal with it. So 5 pi over 4 plus 2 pi n, and 7 pi over 4 plus 2 pi n. Okay, so now for tangent theta equals negative square root 3, let's take the inverse tangent of both sides. So theta is inverse tangent of negative square root 3. And we can think of that as a fraction, negative square root 3 over 1. So where is tangent negative? Tangent is negative in quadrant 2 and quadrant 4. So we would have square root 3 on the opposite and 1 on the adjacent. So here's a 30, 60, 90, and the reference angle is 60. So in degrees, our answers would be 120 degrees and 300 degrees. But in radians, our answers are 2 pi over 3 and 5 pi over 3. So for part A, if you're just finding the answers on the interval from 0 to 2 pi, there you go. And for part B, what we want to do is realize that these answers are actually half a circle apart. They are pi radians apart, so we don't have to list them both. We can just say that theta is 2 pi over 3 plus pi times n, where pi represents going half a circle to get to the next answer. Okay, problem number 3. So let's add 1 to both sides and then divide both sides by 3. And then we'll take the square root of both sides. Don't forget about plus or minus. Square root of 1 is 1 and square root of 3 is 3. And then the inverse tangent. Okay, so let's picture this. So because we have plus and minus, we're going to be in all 4 quadrants. And the opposite will be 1, and the adjacent will be square root 3. So we have a 30-degree reference angle. So in all the quadrants, we have all the 30s. Okay, so then in degrees, our answer would be 30 degrees and 150 degrees and 210 degrees and 330 degrees. But in radians, those would be pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And so that's part A. And for part B, realize that the quadrant 2 and quadrant 4 answers are pi radians apart, and the quadrant 1 and quadrant 3 answers are pi radians apart. And so let's give our quadrant 1 answer pi over 6, and then just say plus pi times n, and that takes us to everything that's in quadrant 1 or quadrant 3. And then let's also give our quadrant 2 answer, 5 pi over 6, and add pi n to that for all the answers that are in quadrant 2 or quadrant 4. Okay, here's number 4, and it's factorable. So we're going to factor it into 2 cosine theta minus 1 times 2 cosine theta minus 1. Now those are the same, so you can write it as 2 cosine theta minus 1 quantity squared. You can square root both sides, and we just have 2 cosine theta minus 1 equals 0. Add 1 to both sides, and divide by 2, and take the inverse cosine. Okay, so where is cosine 1/2? Cosine is positive in quadrant 1 and quadrant 4. 1 on the adjacent, 2 on the hypotenuse, so the opposite would be square root 3. So we're looking at a 60-degree reference angle. So we're talking about 60 degrees and 300 degrees. And putting those in radians, we have pi over 3, and we have 5 pi over 3. So that would be part A. And for part B, let's go ahead and list each of those with a plus 2 pi n tacked onto it to represent everything else that's coterminal with it. So pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n. By the way, it doesn't matter if you use an n. Some people or some books will use a k. Those are the typical ones, n or k, but it really doesn't matter. It's just a letter. Okay, here's the next one, and it is factorable as well. We have 2 cosine theta, we have a -1 and a -3. That will work. And so let's set each of these equal to 0. 2 cosine theta minus 1 equals 0, and cosine theta minus 3 equals 0. So solving the first one, add 1 to both sides and divide by 2. So cosine theta equals 1/2. And take the inverse cosine. I feel like we just did this one. Didn't we just do in the last problem? Inverse cosine of 1/2. Let's look back at it. Yep, we just did. We got pi over 3 and 5 pi over 3. Might as well take advantage of that. Okay, and then for the second one, let's add 3 to both sides. And now we go, wait a minute. That's not possible. You can't have cosine equal to 3 because the cosine graph only goes up to a height of 1 and down to a height of -1. So that part has no solution. So that means we're just left with the solutions we got from the first part. So for part A, we have pi over 3 and 5 pi over 3. And for part B, just like in the last problem, we have pi over 3 plus 2 pi n, and we have 5 pi over 3 plus 2 pi n. Okay, this one is also factorable, and it factors into, let's see here, 2 sine theta, sine theta. We have a 4 over there, we have a 3 over there, that way we get 8, so plus 4 minus 3, that gives us a positive 5 in the middle. So let's set the first one equal to 0, 2 sine theta minus 3 equals 0, and the second one, sine theta plus 4 equals 0. So let's go with the first one. We're going to add 3 to both sides and divide by 2. Look, it's happening again. One that has no solutions because sine cannot be 3/2. The largest sine can be is 1. And then the other one, sine theta equals -4. It's happening again because sine theta cannot be -4. The lowest it can be is -1. Oh boy. We kind of like it when this happens, don't we? Secretly like it when there's no solution because we're like, that's less work. We like that. Okay. Moving on to number 7. Okay, for this one, we're going to factor sine theta out of both terms. So we have sine theta times a quantity, tangent theta plus 1 equals 0. So setting each of these equal to 0, we get sine theta equals 0, and we get tangent theta plus 1 equals 0. So let's solve the first one. So theta is inverse sine of 0. So where is sine equal to 0? Sine is equal to 0 at 0 degrees and at 180 degrees. So let's convert those into radians, and we have 0 radians and pi radians. And now for the second equation, subtract 1 from both sides, take the inverse tangent. Where is tangent equal to -1? That would have to be quadrant 2 and quadrant 4, and that would be a 45-degree angle, so that we would get a 1 and a 1. Okay, so that would be 135 degrees and 315 degrees. So in terms of radians, we have 3 pi over 4, and we have 7 pi over 4. So for part A, these are the answers. And then for part B, what we want to do is take all of these and add 2 pi k. However, actually, because 0 and pi are half a circle apart, we can just write one of the answers plus pi times k. And because 3 pi over 4 and 7 pi over 4 are also half a circle apart, we can just write one of them and add pi times k, or pi times n. So for part B, we have 0 plus pi times n, but we don't need to write 0. So let's just write pi times n. And then for the other set, we have 3 pi over 4 plus pi times n. Okay, we have one more. Sine of 2 theta equals square root 3 over 2. Okay, so let's take the inverse sine, and we get 2 theta equals inverse sine of square root 3 over 2. So remember, sine is positive in quadrant 1 and quadrant 2. Square root 3 would be on the opposite, and 2 would be on the hypotenuse. So that means we have a 60-degree reference angle. So 2 theta is equal to 60 degrees or 120 degrees. Let's put that in radians. 2 theta is equal to pi over 3 or 2 pi over 3. But remember, this is the kind of problem that you want to go around and get a second set of solutions, because you're going to be dividing everything by 2. So going around the circle again, all the way back to the same position in first quadrant, we need to add 2 pi radians to our first answer, and we end up with 7 pi over 3. And then we need to add 2 pi radians to our second answer, and we end up with 8 pi over 3. So for part A, oh, whoops, I'm not quite done yet. Now we need to divide everything by 2. So we have pi over 6. 2 pi over 6 would be just pi over 3. And then we have 7 pi over 6. And then 8 pi over 6 would just be 4 pi over 3. So that's part A. And then for part B, just go back to where we had our single set of answers initially, where we had the 2 theta equals pi over 3 and 2 pi over 3. So we're going to write pi over 3 plus 2 pi n. And then we're going to write 2 pi over 3 plus 2 pi n. And then after that, we divide everything by 2. And we get pi over 6 plus pi n. And we get pi over 3 plus pi n. And those are the answers for B. And that's it. Yay.